Hi, here I have two gas lighters which have basically identical design. Everything is the same and I fill them with the same gas, but they have completely different flame. Let me I show it to you. Turn off the light. One of them burns like this, very gentle flame, blue and yellow. Temperature is moderate, and if you shake it or if you blow to it, the flame will go away. The other one, it burns with a concentrated flame, completely blue, and sometimes if it gets heated, the color of the flame will also change because of some additional part that they added on the tip of the nozzle. It doesn't go away. It's very wind resistant. So I was curious why the flame of this one looks like this while the flame of the other one is like this. Also, we have same thing with a smaller lighter. So for example, this one burns like this, but this one burns like this. Turbo flame, jet flame. Okay, let me I turn on the light and we're going to open them and see what is the difference between the two. Okay, as you can see, everything is the same. We have the gas reservoir. The butan gas is injected here, will be stored here. We have a piezoelectric element. There is a hammer on top of it. So when we press this one, the hammer hit to the piezoelectric element, basically induces charges on both sides, positive, negative. And each side is connected with one wire. One of them goes to the tip of the nozzle and the other one is connected to the body. So when we press it, basically that hammer creates the charge and we have a spark which turns on the flame. These things are identical. You can see that this one has the same design as the other one. A gas pipe, tiny gas pipe, will go to the tip of the lighter and basically release the gas there. For both of them the same. Let us remove this part. Alright, so up to this point they are basically identical. The only difference is the tip of the lighter, the nozzle, where the nozzle is located. So this one has a nozzle like this, and this one up to this point is the same. Here there are some springs here. I will explain to you what the springs are, what I think they are for. We have this piece of plastic, and this is the actual nozzle that is connected to the tip of the lighter. For this one, the nozzle is very simple. The gas comes from this tube. It goes through this nozzle, which is basically a hollow cylinder, and then it goes out, and here the gas will mix with oxygen and we have the flame. But because the mixture with oxygen is not done properly, the flame burns blue and yellow. Also, we have some tiny springs here. We have actually two springs. One is on the outer side and one is inside the nozzle, as you can see. First, let us see what are the purpose of these two springs. Alright, so I'm going to turn on this one without having the springs at the tip of the nozzle. Okay, so we have this one. Everything looks the same. I'm going to very gently blow to it. With that, the flame is gone. Of course, this means the flame is really not stable. Let's now add the spring into the nozzle and see what happens. Okay, we turn it on again. So actually the flame stability is improved by adding those springs. At least this is what I think. Maybe if somebody else knows the other purpose of those springs, mention it in the comment section. Alright, so this is the tip of the soft flame. Here we have also a cover for it. It's very simple. So normal big lighters also they have the same thing. If you look at inside carefully, you can see that there are some springs inside the nozzle. This one, for example, has only one long spring. It doesn't have two. This one has two. One inside and one outside. Alright, so now we look at the lighter with the turbo flame. Basically, up to this point, everything is identical to the other one. At this point, we have a nozzle that makes all the difference. So we have a cover first. The cover goes here and the nozzle goes inside. But in reality, this one is connected here. So the nozzle, in the first part, there is a rubber gasket which basically seals the connection. Inside this reservoir, we have liquid butan. The vapor pressure of these liquid gas at room temperature at 20 degrees maybe is 2 bar. And if the room temperature is more, let's say 30, 40, maybe this vapor pressure can be 3, 4 bars. And so we have high pressure gas inside, and this comes up to this point. Basically, it comes through this nozzle. After this rubber gasket, basically we have a region that is restricted, so very tiny holes are there. So when gas passes through these tiny holes, the speed of the gas will increase. And high velocity gas will pass through the center of these. It will attract the air from the side channel, and basically the gas and the air will mix and then come from here. It comes out, and then we have the flame. In this part, we have a ceramic which has also a specific shape so that the mixed fuel and air will come here and form the jet flame that we have. During the operation, the ceramic actually can get heated, and it causes the flame to stay close to the tip of this nozzle. And after that, we have this metallic shield. At the tip of the metallic shield, we have some kind of metal with salts, which if heated a lot, it can glow red or other colors. I will take a few pictures of this nozzle and show it to you, but this is basically what I have visualized. So this is the inlet. It comes here. These are the gasket, rubber gasket. And then here there is restriction of flow. The speed of the gas will increase here. It attracts air. And here there are chamber which it mix, and then the gas will come out. This is the ceramic and this is the metallic shield. Here are the metal salt or metal composition that if heated it will glow different color. For example, in this case, it produces red color if we wait sufficiently long time. Alright, so that's all for this. I put this one here and then we see how it burns. Does it produce the jet flame right away, or you can see that the jet flame is not very intense. Maybe I should switch off the light. This one's not very visible. The jet flame is actually not that intense because the amount of air that comes here is right now not controlled. Actually, if we put this cover back, oh, it's hot. So I put the cover back and then I insert the nozzle. Even under this condition, maybe the flame still will not be as good as we saw at the beginning of the video, because still the amount of air that goes through this is not optimal. It's not what it should be. So now I'm going to add the cover. Okay, let's see how does it work now. It's a little bit better, but you can see still it's not optimal. So actually the position of the air intake with respect to this one and this one is important. So maybe I rotate it a little bit and then put it back. So the amount of air that is going into the nozzle is important and basically is controlled by these side channels. Just wait a bit so that the flame becomes colorful. If you use the lighter too much, this salt material that is added at the tip of the nozzle will be eventually vaporized and then the color will be lost. So that's why this one does not produce too much red color. But this one is not used a lot. It produces very bright red color. Alright, so now you know why this one burns like this and the other one burns with a turbo flame. See you next time. Bye.